Welcome to a lesson with Dr. Powell. Let's suppose when we're solving a system of equations using elimination method, we get down to something like this. And we can't go any further. Notice that we've completed step 1 and step 2, but we have a problem with step 3. There's really no way to get a 1 into this position with using while keeping these guys the same. So we'll just be finished, really. We're done. Well, how do we read off the solution here in this particular case? Well, notice that z in and of itself, because this is the equation where we'd have a z, really z can be anything, and this bottom equation would hold just fine. We're going to let z be itself and be free. So in our solution, we're just going to say z is equal to z. Z is just itself. It's free. It's not tied down by anything in this system of equations. Really, what we've shown is that our system of equations is equivalent to a system of 2 equations with 3 unknowns. That actually leaves one of our variables as being free and not tied down, so it can be anything it wants. That means the other variables are actually going to depend on it. In some sense, the other variables are like functions of it, so they're going to be written in terms of it. So the solutions really do still work. Let's read this first equation off and translate it in variable form. We have x plus 2z, because that's like a 0 times y. We have x plus 2z is equal to 2 from the first equation. Then from the next equation, we have y plus z is equal to 3. So our goal, since z can't really be solved for, is just to solve for everything in terms of z. So the top equation would read as x equals, we solve for x, and it'll be written in terms of z, that's fine. So this top equation becomes x is equal to 2 minus 2z. This bottom equation right here becomes y is equal to 3 minus z. Okay, so so we end up getting x is this, y is that, and that's our solution, really. 2 minus 2z, comma, 3 minus z, comma, z. Now, what does this mean? This means, well, this gives you kind of a formula for how to get all solutions to the system of equations. There's infinitely many solutions. Recall for a system of linear equations, even in more than 2 variables, you still have this happening. Either there's exactly one solution, or there's infinitely many, or there's none. In this particular case, there's infinitely many. But it depends on z. So it's kind of a formula for how to get it. For instance, what if z were 0? Then plug that z and 0 everywhere. You end up getting this. This is a solution. What if z were 1? Let's see what happens. And plug in z as 1, so you get 2 right there. You end up getting 0 right there. Well, you have 2 different solutions to the system of equations. And you can even get more, plus many more. So instead of listing all these out, we simply just go ahead and circle this guy and say, hey, that's the solution. It's a formula for how to get all of the solutions. This type of system is called a dependent system. Can you guess why it's called a dependent system? Because the solutions depend upon a free variable that's free to move around. It's not tied down in the equation. You can solve for everything in terms of it. So it's called a dependent system. And dependent systems happen when in the process of solving our system of equations, we get a row of zeros. It is possible if we have 2 rows of zeros, that's also a system of equation. That's also a dependent system. For instance, what if we had something like 1, 5, 4, 2, and then we had zeros? This would again be a dependent system. And In this case, there's two free variables. There'd be a y and a z. So basically the solution is just to solve for x only, really, and then y and z are free. So in the solution set, you would have, you would have a y here and a z here as being free. The x, though, would depend on y and z. So we just simply solve for x in terms of y and z. Take this top equation, think of it as x plus 5y plus 4z is equal to 2, and solve. Subtract the 5y over, subtract the 4z over. You would end up getting 2 minus 5y minus 4z. And this would be the solution of this dependent system right here. Thanks for watching.